Hello students, welcome to my channel Explore Physics, Let's Explore. In the previous class, I've explained you about the refraction through a glass prism, dispersion and spectrum. Today I'm going to explain you the formation of rainbow and atmospheric refraction. So, you know that the rainbow, you see the rainbow after the rains. So, what happens there? Each of the droplets which is suspended in air acts like a small prism, and inside the water droplets, what happens, if you consider one ray which strikes at it, say like this, at the interface here refraction happens and it goes inside. When it goes inside, here the dispersion happens because when I'm telling you it acts like a prism, so it splits white light into 7 components. So here the dispersion happens, here it strikes the inner surface of the droplet, and here at this point total internal refraction happens. So inside it is total, after total internal refraction it comes back, and here again refraction happens, that is coming from the water here again. So here again the refraction happens. So what happens exactly? First refraction, then dispersion. Here it disperses into 7 components. So here dispersion happens and total internal refraction happens when it strikes the inner surface of water droplets, and here when it comes out again refraction happens. And here if you have ever observed the rainbow, the violet is at the bottom of the arch and red is at the top. So that is how the rainbow is formed. It is always opposite to the direction of sun. So that also you must remember, that also will come and may come as one of the question. So the direction or the rainbow always happens or always is seen opposite to the direction of to the sun. That is one. What happens? Refraction, dispersion, total internal refraction and refraction again. Which color is at the bottom of the arch or of the rainbow? Violet is at the bottom and red is at the top. So this is all about the formation of rainbow. Now we'll talk about the atmospheric refraction. What happens, how the sunlight comes to us. There's so many, phenomena, optical phenomena which is based on or which occur due to the atmospheric refraction. So now I'm going to explain you about the atmospheric refraction. When the sunlight comes to us, it covers or it crosses over different layers of air. At times there is vacuum. At times the air is optically denser, at times it is rarer. So there are different layers of air and it crosses each of the layer and then it comes to us. You have seen it, the wavering or flickering of light or the objects. If you have ever noticed that when just above the fire, if you can see through the hot air, you can see the objects moving or little shaking. Why? Because as the hot air is rising up, hot air is rarer as compared to cold air, and there the refractive index is less. So because of the random change in because there are cold air is also there surrounded by that, and we have the hot air is also rising up. So because of this, the random change in atmospheric refraction, we can see the wavering or flickering of the objects. Okay, so this is, you can observe it, how does it take, or you have seen it in a smaller scale. So this is what happens in atmospheric refraction. I'll give you one very simple tool. Why to the optically denser medium the refractive index is more, or to the optically rarer medium the refractive index is less. This can be explained by the formula N is equal to C by V. So to the optically denser medium, the velocity is low. Because the velocity is low, the mu or the N or the refractive index is more. To the optically rarer medium, the speed of velocity is more and the refractive index will be less. So that is how, if it's compare it, related like optically rarer means mu is or n is less. The second, this is rarer. Optically denser, it shows that mu is more. So take it this way. So now, so as I was explaining about the hot air, as the hot air rises up, because hot air is less denser, is optically rarer, so the refractive index is less there. So come take it this way. I'll be explaining about the twinkling of stars. Why do the stars twinkle but planets do not? The sunrise, early sunrise and late sunset of sun, all are the phenomena which occur due to atmospheric refraction in the next class. Till then, stay healthy, stay safe, and a very big thank you to you all. Please do like my channel if you like the content.